Hi everyone, today in Integrated Math 2, we're going to go over Chapter 8, Lesson 6. Here are the objectives. Make sure you write them down in your notes. Alright, so trapezoids. A trapezoid is a quadrilateral with exactly one pair of parallel sides. The parallel sides are called bases, which are shown here in red. The non-parallel sides are called legs, which are shown in blue here. The base angles are formed by the base and one of the legs. In trapezoid ABCD, angle A and angle B are one pair of the base angles, and C and D are the other pair. The legs of the trapezoid are congruent, then it is an isosceles trapezoid, if that is true. So, isosceles trapezoids. If a trapezoid is isosceles, then each pair of base angles is congruent. So if this angle is congruent with this angle, and this base angle and this base angle are congruent, then we have an isosceles trapezoid. If a trapezoid has one pair of congruent base angles, one of them, then it is an isosceles trapezoid. So, for example, in our case, angle L is congruent to angle M. Then we have trapezoid KLMP, which is isosceles. A trapezoid is isosceles if and only if the diagonals are congruent. So in this case, QS would have to be congruent with RT. So let's kind of show this in action. So first we have our two sides are congruent. Then we have the base angles. In this case, we have our green ones. And now we have the pink-red ones that are congruent, so good so far. Then we have one diagonal, and the other diagonal are congruent as well. So here's an isosceles trapezoid. Then we have the trapezoid mid-segment theorem. So what this one is saying is BE, so that mid-segment here is equal to half times AF, so the top part, and the smaller piece when I say top, and then the larger piece on the bottom. So let's check this out. So mid-segment of a trapezoid, make sure. So as you see here, this is congruent to this. This side is congruent to this side as well, as this side is congruent to this side here. And what we're going to do is side AB plus CD times a half or divided by 2. And these numbers are saying what each of the lengths are. And we're dividing it by 2. And now it is equal to 7.71. And there we go. And now kites. Kite is a quadrilateral with exactly two pairs of consecutive congruent sides. Unlike a parallelogram, the opposite sides of a kite are not congruent or parallel. We have SP, which is congruent to SR, and then RQ, which is congruent to QP. If a quadrilateral is a kite, then the diagonals are perpendicular, making that 90 degrees. And if a quadrilateral is also a kite, then exactly one pair of opposite angles are congruent. Just one pair. So let's check this out. First of all, we have our kite here. These two are congruent, as these two are. And we have our congruent angles, which is what we needed. Only one pair. And then you see that you have your perpendicular angles, which in this case is right here, which is our 90 degrees. And there we go.